Yep, this is 7.3.
Do you have a pencil?
I do not. Oh, we're asking. What?
The first two questions are the exact same.
Are they the y-intercept questions?
And then the
Cha-ching, easiest questions in the whole world. What is the y-intercept of this function?
net 0, comma, -6.
Oh, good. I just realized it seems like the easiest question in the world, but then it tells you to write it as an ordered pair, which is still easy, but sometimes we forget that a y-intercept is a point on the y-axis, so technically it is an ordered pair. How do you get your y-intercept? It's just your c value with its sign. So the y-intercept is -6, but we have to write it as an ordered pair. -6 on the y-axis, 1, 2, 3, 4, 5, 6. What is the ordered pair for that? Ricky just said it, but I want somebody else to say it. 0, -6, right? So the y-intercept as an ordered pair would be 0, -6. 0, x value, because it doesn't move left or right on the y-axis, so -6 to show that it's down 6 on the y-axis. And that's how we type the y-intercept as an ordered pair. I'm really glad we did this because it's going to be that way on your quiz tomorrow as well. Because I made the quiz by pulling all of the homework questions that I've already given you guys. So you're already practicing all of them for the quiz. Okay, next one. Is everybody good for their specific y-intercept that they got? For this function, what would the y-intercept be for this?
parentheses 0, comma, 7.
Yep. Here's your y-intercept, +7. So it would be 0 for the x value, 7 for the y value on the y-axis, +7.
How would we write that? Wait, if
Oh, for an explanation?
No,
So you would
right.
explain it like this. The y-intercept is the c value in a function.
if your y-intercept line is -9,
Uh-huh.
which is 0,
Exactly, yep. So you would, for your explanation, you would say, the y-intercept is the c value in f of x equals ax squared plus bx plus c.
do you have to put the 0?
You do have to put the 0 because they want it as an ordered pair. So we have to type in both the x value and the y value for where the y-intercept is on the graph.
Miss Lay.
Yeah?
So, is it okay if I wrote this? -7 is the y. Intercept because the c is the y intercept.
Totally fine. I understand that when you guys write out a sentence or a phrase or whatever, I understand it's going to be in your own words. All I'm looking for is that you are processing it and there's a reason why you chose that answer. And this whole purpose of showing work, even though everybody's required to do it, I'm really specifically doing this for the people who I know are not actually processing things and just getting help from their friends. You guys get help from me, so I know we're processing it because I do it with you. Or help from your friend PhotoMath. All right, that was half of it. I suspect that they're going to get a little bit trickier. Okay, so now we have to do 3 things, and I believe that 3 and 4 are the same type of question. This is the one that requires, we did this in class yesterday, but we kind of rushed through it because it was just hard to get through the whole thing. So we're going to go through the steps. When we're given a quadratic function in standard form, the ax squared plus bx plus c, that's standard form, we can locate the y-intercept, the axis of symmetry, and the vertex by doing a series of steps. Now, of course, the y-intercept is the easiest part. We write it as an ordered pair. What would the y-intercept of this be? 0, -3. And then you can fill in whatever your y-intercept is. I'll give you a second to do that. In this case, I would not need you to explain this part to me because you already explained in the previous questions how you find the y-intercept, so you don't need to repeat yourself. Like if you were doing showing work for numbers 1 and 2 and the explanation is exactly the same, you could just write same as number 1, like on number 2 you could write same as number 1 or same, like that would be totally fine. I just need to know you know what you're doing. All right, so we have our y-intercept. Now the axis of symmetry, do you guys remember the rap? Axis of symmetry, 2 times A under negative B. It's got to rhyme, ready? Axis of symmetry, 2 times A under negative B. Axis of symmetry,
2 times A under negative B.
axis of symmetry.
2 times A under negative B.
Angeli, are you cringing? Is this not cool? I'm too cool to rap math. You know what's good about being super old? You're never too cool anymore. The older you get, you don't care about if you look like an idiot. So you guys can start that now. You guys are getting old. Axis of symmetry, 2 times A under negative B. Axis of symmetry, 2 times A under negative B. So for the axis of symmetry, it's 2 times A under negative B. Now, something that we have to remember, let me just go to this next thing here, because I want you guys to see what it's how it's specifically asking you to write it.
Looks like there's 4 parts, 3.
I know there's, whoops, what did I do? What's happening? Yes, you can. What's happening?
Broke it.
I broke it. It went blank. Help!
Just exit it.
Exit and try again.
Yeah.
Okay. When it's asking for the axis of symmetry, it is asking you to type an equation. That equation is going to be x equals something, just one number, x equals something, because an axis of symmetry is a vertical line, an imaginary vertical line, somewhere on your x-axis that cuts through the parabola, cuts it in half, goes through the vertex. Okay, I don't know why we're looking at our Chromebooks right now. Axis of symmetry is somewhere on the x-axis, so the equation is simply going to be x equals whatever that x value is. So the axis of symmetry formula is an equation where you get x equals this when you plug in your values. For A, it's -2. So on the bottom, I have 2 times -2. For B, it's +4. But remember, this is negative B, so I have to do -4. Are you guys with me on that? Okay. So then I have -4 over -4. What does that equal? 1. -4 over itself is +1. So the axis of symmetry is 1.
What would mine be? So mine, like,
Did you plug it in?
yeah, I have it set like this.
Okay, so you have negative b over 2a, so 2 times a under negative b, and tell me what you filled in here.
-6. Well, +6.
Where? I don't
On
know.
top.
So is your b value +6? Okay, so what did you put up here?
Negative and -6.
Good. And what's your a value?
-3.
-3? Okay. So what is it?
1.
Yes. Because you have -6 over -6, that equals 1. It's the same thing. You can't figure yours out either?
No.
Did you plug it in?
Do we have to put it in like the fraction?
You say x equals 1. Kelly, what?
It's that it equals -2.
I'm confused. What equals -2?
It's mine is like -x squared subtract 4x plus 30.
So, I'm sorry, say it again, give me your whole function.
That's
f of x equals,
-8 squared.
I can't hear you.
-x squared
-x squared
subtract 4x
minus 4x
plus 13.
plus 13. Okay, so yours is a little trickier because your a value is semi-invisible, right? What is your a value?
1.
It's not 1, it's,
0.
X negative.
it's,
-0.
it's -1. Negative x squared is -1x squared. So the one part they made invisible because they don't have to show it. But the negative part means that it's a -1x squared. So your a value is -1. Is that what you were having trouble with? Plugging in the -1? So for yours, in your denominator, it'd be 2 times -1. And then your b is a -4. Now this is also tricky, because the formula says it has to be negative b, which means negative times your b value. Negative times your b value, which is also negative. So you have a -4. Simplify that, a -4 is a +4. 2 times -1 is -2. Divide those and you get -2. So yours is x equals -2. Did everybody get their axis of symmetry? Good. Are you good, Kelly?
Yeah.
Okay, now that we have the axis of symmetry, that's gonna be what we use to find the vertex.
I know what the vertex.
What?
What?
What'd you say?
I know what the vertex is. I think.
Did you actually solve for the vertex, or did you just
I think so.
you plugged it back into the function?
Yeah.
You did?
Sort of.
Sort of? Okay. Walk me through it.
Oh, whoa. Isn't it 4 times -6?
No. The vertex is an ordered pair, and the vertex is a point on the axis of symmetry.
Oh.
If the vertex is on the axis of symmetry, okay, so our axis of symmetry is 1, x equals 1. That means that our axis of symmetry is this invisible line on x equals 1. The vertex is a point on the axis of symmetry, meaning we already know one of the coordinates of the vertex. What coordinate do we know?
1.
We know the x coordinate, right?
Oh, yeah.
Because whatever point it is, the y value could be anything, but the x value has to be 1 because the axis of symmetry is x. Literally, the axis of symmetry is x equals 1, so use 1 as your x value. What's going on over there, Giggle Girls? Is this recording? Okay.
So it's one.
So it's one something. We don't know what the y is yet. We have to solve.
What?
Okay, so the vertex is going to be, for me, because that was my axis of symmetry, whatever your axis of symmetry is, that's going to be the x value of your vertex. How do we find the y value if we know an x value? That's the y-intercept. That's going to be the point on the y-axis that it goes through. So we can plot that just out of curiosity. So -7 would be 1, 2, 3, 4, 5, 6, 7. So down here, that's going to be a point on the parabola, but that's not my vertex, that's not anything that on that axis of symmetry. How do I find my y value if I know my x value? What can I do? It would not be 0. Plug it in. I would actually have to solve for the output by taking this input and putting it in, that's why we call it an input, put it into the function, the machine, and see what comes out. Remember, what comes out, our output, is also our y value. So we're going to take our function, and every time there's an x, I'm going to sub in +1. So I am inputting +1. That's why instead of saying function of x, I'm saying the function of this input, +1, is going to be -2 times x, which is +1 squared, plus 4 times the input, or x, which is +1 minus 7. All I have to do is simplify this to see what the machine or the function is putting out. Does that make sense? We're just taking our x value from the axis of symmetry, plugging it in to get the y value for our vertex. So now, this is very important. We do not multiply these. Don't do it. That's breaking all the rules of PEMDAS. Well, not all the rules, but a big rule. What do we do first? Okay, what's inside the parentheses? A 1. Done. Parentheses are done. What's next? Is it called PEMDAS to you? Exponents. So we have to solve this first. 1 squared is 1. Then we multiply it times 2. So what does this simplify to? What is this part simplify? Simplify this? Well, we just did. I just want you to tell me the number. Good. Callie's holding up 2 fingers for anybody who didn't see.
You just did 2 times 2.
No. 1 squared is 1. Multiply that times 2, and you get 2.
What?
1 squared is 1 times 1. Then multiply, 1 times 1 is 1. Multiply that 1 times 2, and you get 2. I feel like I'm starting to talk like a kindergarten teacher, and I think it's because I'm not getting a whole lot from you guys, so I feel like I need to talk like this. So if you guys could interact a little bit more, that'd be helpful. Does everybody understand how you get 2? If you do it the wrong way, you're gonna get 4. Oh shoot, I forgot about that negative. Is that what you were about to say?
Oh crap.
Thank you for being the one person to point that out. I didn't even see this negative. I was so focused on PEMDAS. Multiply that 1 times a -2, and you get -2. Thank you. Now, next part about PEMDAS is we have to continue with our multiplication. Do not add 4 to this. We have to multiply the 4 times the 1 first, which will get us 4. So it's +4 minus 7. Then we go from left to right. Or we can just circle our terms with their signs and combine. We get -2 plus 4 is? -2 plus 4 is? No. 2. 2 minus 7 is? Or 2 plus a negative 7 is? Negative 5.
Oh wait, I said I was going to say that.
So the function of 1 is negative 5. Meaning when a 1 goes in, a negative 5 comes out. And that, my friends, is your vertex. 1 and then negative 5. 1, 2, 3, 4, 5. If you were to use your parabola tool on in Savas, graphing those 2 points will create a parabola. But if you're doing it by hand, you do need a third point to create it. How can I very easily, just by looking at this, graph my third point? Hello? How could I graph my third point just by looking at this? I know my vertex, I know my y-intercept, and I know my axis of symmetry. How can I graph a third point on this parabola just by looking at what I already have? I don't even need my function, I don't need my numbers, I'm just looking at it. How do I graph my third point just by looking at it? So from here you go up to over 1, that point is already there.
Yeah, I need to do it again.
Up to over 1, so we're graphing a line?
I need to do it on the other side. So go to the bottom one,
Like this?
and then go to the right.
Like this?
And then one.
Like this? Okay, so here's the axis of symmetry. This is what creates the symmetry of the parabola. It cuts the parabola in half. Yes?
I think she means like go up to and then go to the left.
From here? So up to and go to the left one?
Yeah.
How in the world could this be the parabola if this is our axis of symmetry? The axis of symmetry is supposed to be where the vertex is, where it's cut in half. Yes.
Yeah, so go to the other.
This?
No, not the other.
This one?
You go down to and then go to the right.
Okay, totally correct, but you don't even need to start at the vertex. You just take the point that's not the vertex, find out how many units you need to go to the axis of symmetry, and then go that many units to that point. If it's 1 unit away from the axis of symmetry, then go 1 unit from the axis of symmetry. That's your other point. Now again, in the Savas tool, it will do that for you. It will just require you to graph 2 points, and it will just make that parabola. But if you're actually graphing it by hand, you can just count across the axis of symmetry. Does everybody understand? Did somebody say no?
No.
All right, I'm going to go to question 4 because I don't even know.
Wait.
What? Okay, this is the same exact question. Does anybody want me to do another example? Yeah? Okay, because this is question 20 on your quiz tomorrow.
The thing is, that one, it has a positive. It has a positive.
Oh, so, and this, okay, so this one has a positive, the other one had a negative? Okay.
And it also has a different y.
Yeah, it has different numbers. We'll deal with positives and negatives, but the process and the formulas are exactly the same. So, find the y-intercept, the axis of symmetry, on the vertex. Y-intercept, what is it for this one?
13.
13. How do we write that as an ordered pair?
0, 13.
Very good. 0, 13. Y-intercept is done. Now we need our axis of symmetry
2 times A over
under.
negative
Yeah. Axis of symmetry.
2 times A under negative.
Good. So axis of symmetry is 2 times A under negative B. And we know that that is going to be the x equals value because the axis of symmetry is on the x-axis. So let's plug things in. It's going to be negative b. So I'm going to fill in my b, which here is negative 4. This is very similar to Callie's problem, but it's positive. The A is positive. And then 2 times A, the A is
And then 1.
1.
And just like,
Yeah,
for that question, that the A can be positive and negative.
positive.
And-
Right, because you guys might get a negative. Yeah, so you would just fill in a negative number. Okay, so negative negative is a positive 4 over 2 is 2. Positive 2, that means x equals 2. That is your axis of symmetry. See how easy that is to get? You just plug your A and your B into the formula and slap on an x equals, and now you have, now again, it's not asking you to graph it, but since it's nice, easy numbers that fit on my coordinately, I'm gonna do it, x equals 2, that is the, okay, I'm gonna graph my y-intercept, which is 0, oh, 13, I can, it's all the way up. Okay, so I'm gonna just graph my axis of symmetry just so I can see.
Just like, just put another mark on the wall.
Oh yeah, not gonna do that, I've already got all my
2.
stains up there. Okay, so now I have my axis of symmetry. I'm just graphing that so we can see what it looks like. How do we use our axis of symmetry to fill in half of the vertex? Yes, the x value or the x coordinate of the vertex is your axis of symmetry, which is 2. Now we need the y, or also known as the output, for when a 2 gets put in. How do we solve that? Plug it in. Very good. So if I have the function of x, I'm going to say that 2 is going to be my x value for this function. I'm going to put in a 2, and I'm going to get 2 squared minus 4 times 2 plus 13. Do you guys understand why I plugged in 2's in both of these spots? Do I need the parentheses here? Nah, it's a positive number. If I didn't have the parentheses, it wouldn't change anything. But I like to stay in the habit of using parentheses so that when I do have negative numbers, which does make a huge difference, I'm in the habit of doing it so I won't forget. 2 squared is 4. Why am I the only one talking? Negative 4 times 2 is?
8.
Negative 8.
Oh wait, I was thinking squared.
And then positive 13. 4 minus 8 is? Negative 4. Plus 13 is? Positive 9. Very good. So our vertex is 2, 9. And that's it for the homework.
Wait, what?
Yeah.
Can you help me with one?
Yeah.
Oh, yeah.
Okay. What's your function?
F of x equals x squared minus 6x
Minus 6x.
plus
13? 14. Okay, did you get your y-intercept?
Yeah.
What is it?
14.
Give it to me. Give it to me as an ordered pair.
0 and 14.
Okay, 0, 14. Good. Did you get your axis of symmetry yet? Okay. Just tell me how you did it because I haven't done it mentally. I just want to make sure it's correct.
For the B, I have negative, then parentheses, negative 6.
Good.
Then on the, then the 2A, I have 2, then parentheses 1.
Good. What'd you get?
X equals 3.
Perfect. So we have x equals 3 for the axis of symmetry. So you have 2/3 of it, totally correct. So you just need help with the vertex? Okay. So what, can you give me half of the vertex?
No.
Can you give me one of the coordinates? Really?
I don't know.
What did we say is the x value of the vertex? Yeah, it's the axis of symmetry.
Oh, 1 then minus 6 squared.
Wait, what?
Figure out-
So the vertex is an ordered pair.
Oh,
What coordinate?
3.
Good, so we know that there's a 3. We don't know the y value yet. We have to solve for it. How do we do that?
So we plug it in.
Plug it in. So, f of 3 equals, I just erased the function, so I don't remember what it was. What was the function again?
1.
What was your first term of the function? It's in there. You have it.
And well, it's x squared.
It's x squared? Okay, so how do we write that when we're putting in a 3?
1. The x is 1. I don't know.
Let's write your function again. Sorry, I erased it. What f of x equals what?
1 of x squared.
Okay.
X
X squared minus or plus?
minus
Minus 6x
plus 14.
plus 14. Okay. I'm going, what am I plugging in for my x value?
3.
Good. So how do I write that? Okay, instead of writing x squared, I'm going to substitute my x with this input. Why are you saying 1?
Because you put the line for the x.
You mean this?
Yeah.
Okay. Our invisible ones, we definitely like to make them show up if we need them. Do you want to make that show up? You can if you want to. If you love ones so much, you just want to make, you don't want them to be left out, you can do that. But it's not really necessary. What's 3 squared?
9.
Good. What's 9 times 1?
9.
Good. So, didn't change anything, right?
No, I was just confused because like why aren't you adding
Adding what?
the line?
Adding?
No, not adding. I don't know.
Why did I not include it?
Yeah.
Okay. Because we only include invisible ones or invisible numbers when they matter to what we're doing. Do you understand what I'm saying? This invisible one matters if you are doing your axis of symmetry. Because this axis of symmetry requires you to substitute A with a number. That number is 1. The function is x squared, or 1x squared. If you want to write 1 times 3 squared, that's totally fine, but you don't need it. It doesn't change anything. Does that make sense? Okay, so if you wrote this and you plug in your 3 here, and you do 3 squared times 1, totally fine. I'm just not gonna do that because it's extra stuff that doesn't change anything. I only use my invisible numbers if I need them, if they are going to affect something. This formula requires me to substitute this A value with this invisible one. Subbing in an input for your x does not require me to use the invisible one. You can, won't change it, but it doesn't require it. So 3 squared minus, then what?
6.
Mhm. Yeah, you could just say 6 times 3, or negative 6, oh, times 3. Okay,
11 plus 14.
good. And all we have to do is solve it now. How do you do that? Where do you start?
3
What's that?
9.
Good. What's next?
The 6, -6, 8.
Use the names for the operations. We don't say -6, 3.
6 minus 6, 8.
What's the operation that it's showing? Operations are addition, subtraction, multiplication, division, exponents.
Multiplication.
Yes, this is -6 times 3. So I just want you to be able to verbalize that. Okay, so do that.
-6 multiplied by 3.
Yeah, no, tell me the answer.
-18.
Good. All I'm trying to get you to do is tell me the actual expression, the actual operation that we're doing, and then tell me the answer. So -18 is correct, and then we still have our +14. What do we do next? Yeah, if you want, you can circle the terms with their signs and then just add them all up. You can add them in any order you want. Like if you want, you can just add your positive numbers first. So you can do 9 plus 14, or you can get your calculator out and do 9 minus 18 plus 14. Is that easier for you? Okay, what'd you get? 5? Yes, that's correct. So what does that mean for our vertex? 3, 5.